Okay, so yeah, so we worked on our positive and negative numbers. Okay, we talked about, right, exponents and roots. Okay, so hopefully everyone's still feeling like all of this stuff is solid for you. Okay. Then we did some stuff with this idea of an expression and evaluating an expression using the order of operations to simplify the expression. So is everyone still feeling good about just numerical expressions? Does everyone feel good about following the order of operations? Thank you, Brittany. Are there any questions? Does anyone feel like this was, and you can tell me in the chat, because I can definitely give us a little bit more practice here, but I just wanted to make sure, like we said, we have to build from this foundation. So if you feel like it's still a little shaky, it's okay, because, we haven't really done that much practice, but this is kind of our starting point. Okay, so hopefully everyone feels mostly good with this stuff, and like I said, we'll definitely practice. Okay, so then we went into the idea of the meaning of algebra. Okay, and of course, the big thing that makes algebra is the use of a letter to stand for an unknown number. We call that letter standing for an unknown number a variable, and most oftentimes, right, we like to use X. Probably just because we don't use X for a lot of words, at least starting words in English. So anyway, I guess I still need to see. I'm sure I just need to Google it. Anyway. All right, and so then, okay, when we have a variable along with some numbers, creating numbers and mathematical operators, creating an expression, when we add an equal sign and a value on the other side of the equal sign, now we've created an equation. So hopefully everyone's feeling good. We need to know this language, right? Because it's just going to help us learn and know what we're talking about. So, and definitely tell me, slow down, hurry up. You're boring me to tears. Can't you hear me crying? Okay. Anyway, sorry. All right. So definitely terms like variable, right? And then equation. Okay. Terms like expression. So an expression doesn't have an equal sign, and we can only simplify it to a certain point, whereas, right, an equation, we're solving for our unknown, our variable. Okay. So hopefully that's still feeling good for everyone. Okay. All right, so then we talked about algebraic expressions. So before, right, on our review page, we were looking at numerical expressions, okay? But, right, of course, the presence of a variable along with mathematical operators and numbers, right, is what now says, hey, we have an algebraic expression. So definitely one of the skills that you will be tested on in the GED, right, is being able to interpret, right, these word expressions into algebraic expressions and equations that you can solve. Okay, so we practice that. So I think everyone's hopefully once again feeling good about translating our word expressions into algebraic expressions. Okay, very important, because of course it won't be this easy on the GED, right? It'll be more complex, but this is our starting point, and this is where we want to begin. Okay, so hopefully everyone's feeling good about that. Okay, So we continue to talk about variables and expressions. Good. How are you?
So,
Yeah, pretty fine too. To reprogram AC in this building, but other than that, I'm fine. Like, takes forever to cool down. And then it probably cools down too much.
went on today, nothing.
Yeah, of course. Yeah, we're always up. We're doing, so because this is Tuesday, Thursday morning, we're doing our percents on Tuesdays, and then we're doing more algebra on Thursday, or yeah, so percents on Tuesday, algebra on Thursday. So we're on this one with the house on the front. Okay, and we're just kind of reviewing what we went over on last Thursday. Hopefully all you folks on Zoom signed in and everything. All right, so once again, thinking about how it's written versus how we need to write, kind of translate it into our algebraic expressions. Thanks, Brittany. And then, right, so basically, right, just kind of doing these visuals where if, right, the length from A to B is 3x, and the length from B to C is 7, then the length from A to C is 3x plus 7. So hopefully those visualizations are making sense and everyone's feeling comfortable with that. Just a moment. Okay. Two tries on that projector. All right. So please stop me if there's any questions or anything we need to go over, okay? But hopefully this is feeling good. Okay. So just more practice with our algebraic expressions. Hopefully everyone's feeling like we beat that dead horse. Now the next piece, right, to this is what we call evaluating algebraic expressions. So now, right, they're going to give us a value. Thank you. They're going to give us a value for our variable. So they're going to say, right, if n equals 6, right, and we have the algebraic expression 4 plus n, right? If n is 6, then, right, 10 is our answer, okay? And then remember that, so whatever value they want us to use, we plug it in for our variable into our expression, and then follow the order of operations to simplify it, okay? So that's where we kind of left off. I think everyone was doing pretty well with this. So we ended up basically on the last full page here. So this would be the second to last page. And so hopefully everyone's feeling good about, right? So here, they want us to use x equals 10 for these 9 problems. Whoa, okay. So if x equals 10, right? So we look at our expression, we plug in a 10 where our x is. Now I have 2 plus the quantity 10 minus 1. And so of course, following the order of operations, right? I work inside my parentheses first. Okay, so 10 minus 1 is 9, 2 plus 9 is 11. So go ahead and work on the remaining. Just, you can do the 9 problems up top if you get done, if you just read through those, then move on to 10 through 18. But go ahead and practice that, right? So we think about the right, so first, right, we substitute 10 where the x is, okay, and then oop. Oop. Alright, so hopefully everyone's remembering this. Hopefully the example on number 1 is enough to help you know what to do. You got those 9 marked out, Spencer? Oh, no worries. I was just curious. No, you're good, dude. Alright, make sure you know, right, the dot is multiplied, right? Yeah, you're good, dude. Like I said, just please let me know in the chat, or you can put your hand up or whatever. Once you have these 9 at least worked out, like you said, you can move on to the next chunk. Just remember for, right, 10 through 18, then now, right, x equals 12. Another minute or so maybe for these 9, or are you guys done with the top 9? Okay,
I need more time.
okay, more time is fine.
I'm ready to move on to the next one.
Oh, thanks, Brittany. Anyone else want or need more time, at least on the top 9? Okay, hopefully this felt doable. Hopefully you felt like you knew what to do. So, right, for number 2, right, we're gonna insert a 10. So then 10 plus 3 is 13, right? And then 15 minus 13 is 2. Okay, hopefully everyone got that one. Number 3, right? We're gonna put our 10 right here. So 10 minus 5 is 5. 4 times 5 is 20. Here, 10 minus 6 is 4. 20 divided by 4 is 5. Here, 5 plus 10 is 15. 32 minus 15 is 17. Okay, great. Did anyone get this one? I was like, I'm not trusting my mental math right now. 32 minus 15. Okay, yes. Thanks, guys, for helping me be confident there. All right, and then here 10 minus 2 is 8. 3 times 8 is 24. Okay, 14 minus 10 is 4. 10 plus 4 is 14. Kind of very circular one. All right, 10 minus 4 is 6. 66 divided by 6 is 11. Okay. 10 plus 7 is 17. 19 minus 17 is 2. Okay. How's everyone feeling about evaluating the expression? Because definitely this is on your progress test for sure, and definitely going to kind of look like something you might have to do in the question. Do we need to practice this more, or is everyone feeling okay? do we want to go through the other 9 problems at the bottom or, pardon?
Work on it.
Okay. Did you guys, was everyone able to finish 10 through 18? If not, go ahead and start on at least 11 through 18. Okay, yeah, go ahead and try the next set. So remember, now x equals 12. So we're just doing the same thing. Okay. So hopefully my modeling helps you feel more confident about what to do. But definitely does not hurt to practice, guys. I appreciate your input. So let me know when you're ready to talk about these 8 problems, okay? Have these ones done, Spencer? Good. How's everyone doing on these ones? Need a couple more minutes?
Yeah, I need a couple more minutes. I was putting 10 as the X. That's what we do it.
Which one?
I put 10 as the X and there's 12. That's what we do it.
Few more minutes and then we'll talk. All right. Still wanting more time, guys? Okay. Another minute or so and then we'll. All right, let's go ahead and just look at these ones. So if x equals 12, right? So we start here with number 11. 12 minus 7 is 5. 5 divided by 5 is 1. Okay. Number 12. 12 plus 1 is 13. 13 plus 3 is 39. 13, 12 minus 2 is 10. 10 divided by 2 is 5. 14, 3 plus 12 is 15. 15 times 6 is 90. That sounds right? Okay, cool. All right, and then number 15, 20 minus 12 is 8. 8 divided by 4 is 2. 13 plus 12 is 25. 25 divided by 5 is 5. 12 plus 10 is 22. 22 times 10 is 220. 32 minus 12 is 20. 20 divided by 10 is 2. Did it feel better the second round? Was it easier, harder, the same?
It's confusing because it was multiplying and dividing.
And yeah, since it's inside the parentheses, we're always going to deal with that. Whatever answer we get there, then do whatever the outside says. Okay. All right, let's turn the page or turn to the last page here. So just to remind ourselves, okay. So here, hopefully everyone's still remembering, what does this mean? 3 to the third power or 3 cubed? Anyone remember? We see this
3 times 3 times 3.
Exactly.
9.
Exactly. 3 times itself 3 times. Good. So 3 times 3 times 3 gives us 27. Okay. So then 27 minus, and it looks like x equals 4. Okay. So 27 minus 4 equals 23. This is the very back page, Spencer. Okay, so hopefully everyone remembers how to deal with, and so exponents first, multiplying and dividing. Okay. All right, so does everyone feel like you know what to do for numbers 1 through 9? Hopefully. Yep. Good. Okay, and then go ahead and work on 1 through 9, and then work on, let's look at, 8 through, well, hopefully 10 through 18 will also make sense, okay? But go ahead and work on these ones, see how they go. They should be the same. Just remember, deal with your exponent, deal with your multiplying, then do adding and subtracting.
So on number 4.
It's a multiply sign.
Number 4 is at the 4, right? 94.
No, so this is
Time.
9 times 4, yeah, and then make sure you do your 2 squared and then divide the 2 answers together. Good question. You need a calculator, Spencer?
Yeah.
Feel like I'm gonna need a calculator. Number. Maybe another 3 minutes or so on these ones.
I was dividing first before I do the negative, right?
Yep, so divide 256 by 4 and then subtract it by x squared. Yep, good. X squared, and then divide, and then subtract. All right, maybe 2 more minutes, or are you guys good to go? Longer? All right, let's go ahead and start just working through these, just because I know we need to kind of progress here. So let's see how we're doing. So for number 3, right, 10 squared is 100. 10 times 4 is 400. Okay, stop me if I need to explain more. Okay, and then here, 2 squared is 4. 9 times 10 is 90. So then 90 divided by 4 is what? Does that work? 90 divided by 4. 22 and a half. Is that what you guys got? Oh, I'm sorry. Sorry, for some reason I'm still doing x equals 10. Sorry. X equals 4. Sorry. So yes, that sounds much better. 36 divided by 4 is definitely 9. Sorry, guys. Okay, you passed the test. Good job. Okay, number 5, right? 3 squared is 9. 4 times 4 is 16. So 16 plus 9 is 25. Here, 2 squared is 4. 3 times 4 is 12. So 12 minus 4 is 8. Number 7. 4 squared is 16. 16 plus 3 is 19. Let's see, 4 cubed. 64? Does that sound right? Yeah, okay, so 64 minus 6. So number 8 is 58. And then 4 squared again, 64. 64 times 2 is 128. Awesome. All right. Number 10 or 11. So 8 squared is 64. 64 divided by 2 is 32. So then 64, is that right? 68. 100 minus 32. Yay. Good job. All right, let me just check the chat here for a second. Okay. All right, let's see. 8 cubed is so 8 times 8 times 8, 512. And then we're going to divide that by 16. So then 320 divided by 32 is 10. All right. 8 squared is 64. And then remember, we're going to work left from right. So 78 minus 64 plus 7 is 21. So here we have 64, but we have to do our dividing before we do our subtracting. So 256 divided by 4 is 64. 64 minus 64 is 0. All right, here, right, we have to do our multiplying before we do our adding. So 64 times 4. I know we've done this a million times. 66 plus 6 is 262. So 64 times 4 was 256. 256 plus 6. Don't worry. Here. So once again, 8 squared is 64. 64 divided by 4 is 24, 16. And then 100 minus 16 is 84. Okay. All right. So whoop that 9 cubed, 9 times 9 times 9 729 divided by 9 plus 64. Okay, so then 729 divided by 9. $729 divided by 9 plus 64. You get 145? Cool. I know you said that and I just didn't hear it very clearly. All right, and then why do I keep forgetting what 8 cubed is? Is it 256? No, it's 128 or 512. Okay. I don't know. I don't know. 512 plus 64 plus 16. You guys get 592 for 18? Yes? Maybe? Any questions or problems with these? Are you folks on Zoom feeling like you're getting them, getting most of the answers? Am I going too fast, too slow?
I kind of got stuck on the fraction part of it, 11 and 12.
Okay. So rather than seeing it as a fraction, Brittany, does it help to think of it as a dividing?
And I see you work on it. I could see it, but just like when I had to
Okay.
do it by myself, I couldn't.
So definitely when you have a situation like you see in 11 and 12, right? They made it look like, right? They make it look like a fraction, but you're really just doing a dividing problem, right? So you're still inserting your 8. 8 squared is 64, and then you do your dividing. So yeah, just always think about it as the top divided by the bottom. And really, yeah, for algebra, we'll kind of need to have a fraction brain, but most of the time, right? Definitely. But that's really a good point, Brittany, and definitely getting used to kind of recognizing it. So once again, if it's just the variable on top and no other numbers over here on this side, right? No, what we would call a coefficient. Yeah, then think of it as division. If it has a number here and something on the bottom, then it's a fraction, right? If it's like 3x over 4, right, for example, right, it's the same, right, as 3/4 x, right? Or you could also think of this as, right, 3. Oh, wait, sorry. Right, you can split it out too. But yeah, good point. And yeah, I think we'll get a lot more practice with that. So yeah, just trying to kind of train your eyes to notice effectively. So yeah, definitely if you notice this pattern, oops, sorry, this pattern here is, so we just got our variable hanging out top. It's okay if it has exponents, just as long as it doesn't have what we call a coefficient or a number next to it, like the 3 here. Or 3x. All right. Good work so far, guys. Let's take a break. I think we're ready. We earned it. Okay, so we'll take a 10-minute break. So we'll take a break till a little after, like, yeah, 11, 12-ish, since I went a little over. Okay. And then we'll transition into our next step in the algebra realm. Does anyone feel like you already really know this well and you don't need to go through it? Or is this a useful topic for you guys? Spencer, how you feel about it? Useful to you? About this basic algebra stuff? Do we need to go through it?
I mean.
Good, yeah. If it's refreshing, then that's even better. If it's useful, that's great. But if anyone's, like I said, if anyone's feeling like I did this in 8th grade, can we please do something harder? I want to know that too. About another 2 minutes and then we'll get back into it.
One.
All right, let's continue. So kind of similar to the last packet that we started, the first page is from the previous lesson. So we're actually going to start on the second page where it says chapter 5. If you want to look at the chapter 4 review questions, you can. But we'll go ahead and there. Excuse me. All right, let me grab it. Oh. All right. Uh-oh. Okay, hopefully those are gonna go away. All right, so hopefully everyone on Zoom was able to click the link to the Google Drive and get the new. Oh my God. And got the new materials, hopefully. All right, let's just. Goodness. I'm gonna have pickups for the rest of class. So, do that. All right, according to our book here, algebra is a language you can use to solve real life problems. A word expression can be translated into an algebraic expression. A used car dealer has a sale in which he will sell a car for $1,500 less than the sticker price of any other car on the lot. The phrase $1,500 less than the sticker price of any car on the lot can be translated into the algebraic expression minus 1,500, in which n represents the sticker price and minus 1,500 represents, and so I think we've already done most. Our first lesson really should just be a review of what we just previously did. Real life situations involving numbers and relationships can be translated into equations and inequality. A pattern can be generalized by using expressions and equations. Patterns can be numerical or visual. So anyway, that kind of gives us an idea of what we're going to work on. So if you look down here at the bottom, right, we've already focused on expressions. So I think we should be able to get through 1.5 well. Then we're going to look at 1 and 2 step equations. Then we're Goodness gracious. Then we're gonna look at what are called inequalities, which is kind of a subcategory of equations. And then we're gonna look at this pattern identification stuff. Okay? So this should get us a pretty solid algebra foundation and help everyone remember. Don't worry too much about the goal setting page. Let's just jump ahead. And so lesson 5.1 here should be, excuse me, right, review. Okay. So, right, we have these numerical expressions. Just to remember, oh, goodness gracious, guys, I'm so sorry. Just to remind ourselves, I might have to excuse myself here. If I can fix this, okay? But hopefully everyone's remembering. So what we see here are numerical expressions. Right, and they consist of numbers and what we call operators. Right, and our operators are our math symbols, right? This one, right, tells us to add, right? This one tells us to subtract, divide, multiply, okay? And of course, exponents are also kind of operators, okay? Goodness. All right, so that's what they tell us here, right? And so they give us our definition in this next paragraph. A numeric or mathematical expression, okay, is any combination of symbols, numbers, and operations. So I guess by symbols, we might mean negative signs. By operations, right, we're actually talking about doing the adding, subtracting, multiplying, or dividing. Mathematical expressions can be used to represent many different things. Multiple expressions can be used to describe the same object, right? So of course we know that, right, the 5 times 2 and 6 plus 4, right, have the same outcome when we simplify those expressions. Okay, but of course here they're saying, right, well, we might use 2.5 to represent the total number of players on a basketball court, right? Because there's 2 teams with 5 players. Whereas, right, we might use adding, right, to represent the total number of fruits, right? 6 apples, 4 oranges bought at the store. Okay. So an expression can be thought of as a whole or thought of as a collection of parts, right? So that's really important, right? Because we can always simplify our expression down into a whole if we have, right, numerical expressions, okay? So I think everyone is pretty good on this piece, okay? Right, so you have -3, 5 times -8, 78 minus 23 times the quantity, 2 plus 1, okay? So everyone should, right, know at least what to do if you see expressions like that, okay? And of course, we're always, right, what are we doing? We're simplifying, right? So we've done this, okay? So then, right, a variable or algebraic expression, right? So we're making this distinction, right, between our numeric or mathematical versus algebraic, okay? And of course, the difference is that now the algebraic expression has 1 or more variables compared to mathematic that only has symbols, numbers, and operators, okay? We know what a variable is. A symbol that stands for an unknown number or value. Don't worry about how it's written in italics. I don't think that's super important, okay? So a number that multiplies a variable is called the coefficient, okay? A number that is added or subtracted in a variable expression is called a constant term, okay? So inside most algebraic expressions, you're for sure going to see a variable. Oftentimes we're going to see a coefficient, and other times we're going to see a constant. Okay, so for example, if you look at this expression right here, right, 2L plus 2W, okay, how many variables are in this expression? Anyone know? Am I tricking you? There aren't really variables in this expression. Thank you. Thank you, Tyrick. I appreciate it. Yes, right. There's two variables in this expression. And what would we call this two? This two that's being multiplied to the variable. What fancy word up here would we use to talk about this two? Right? So it's called a coefficient, right? So this is 2 times L, right? 2 times W, okay? And of course, because there's variables attached to both of those coefficients, there's no constants, okay? In this expression here, okay? So yeah, and then you can also, right, use the distributive property to write it like this. So hopefully everyone agrees, right, that these are equivalent expressions, right? Two ways of expressing the same idea, okay? All right, let's continue on, unless anyone has any questions. Okay. So once again, right, just practicing identifying the pieces of the coefficient or the expression, excuse me. So if we have 2 plus x, x is the variable. Why does it say the coefficient is 1? I don't see a 1 in this expression. So how is the coefficient 1? Magic? So all this is telling us to do is just anytime, right? And we see this in the second example too, right? So if it's just the variable by itself, we basically imagine a coefficient hanging out in front of it, right? So it's like, right, there's 1x, right? There's 1m. We just call it x or m, but hopefully you guys get used to, right? Like I said, kind of always thinking there's kind of a secret one, right? And that just means we have one of them. If it's right here, 3n, right, is n plus n plus n. Because you have 3 of them. We just don't know what n is. Okay. So, right, this is 1x, 1m, but if we have 3n, it's the same as this expression. Okay. So hopefully when you look at your expressions, you look at where your variables are. If it has a coefficient, that means we have 3 n's, n plus n plus n. We have one variable, it's just 1. Okay, so hopefully that feels good. Okay, All right. Let's move on to the next page. Okay, everyone's doing well. So we're just looking at these examples. So I think we've worked on this, right? 5 less than twice a number is going to look like this. Okay. I think everyone was saying they're feeling pretty good about these translations. Okay. So I'm sure we'll get some practice on that. All right, so here they have what they're calling a real world situation example. So Tomas has a cell phone plan that charges a flat rate of $35 per month plus 25 cents for each text message. So kind of an old book, right? Luckily, we don't have to worry about that too much these days. Anyway, write an algebraic expression that shows the monthly fee for Thomas's cell phone plan. Okay, so first, right, we're going to assign a variable to the unknown value. Okay. So, right, and here, right, this is our unknown, right? Okay, so we're gonna let the unknown value is the number of text messages, right? Because his monthly bill relies, right, on, or it, is based on how many texts he sends on top of these other fees, okay? Identify the operation or operations in the situation. So of course we get, right? So here, right, we know we just have a flat rate, so that's plus $35. You're always paying at least $35 a month. And then, right, plus, right, so that's our plus, right, 25 cents for each text message. So remember that our text message is our unknown value, okay? So, right, plus indicates multiplication for each text message indicates multiplication, okay? Hopefully everyone's getting that sense, right? So there's always like something per whatever, that's always multiplying, right? We're doing some kind of unit rates, so we have to multiply. It's 3 pounds for $1 and I have 5 pounds, then it's gonna be like $2.50. Okay. Then we write the algebraic expression. $35 is the monthly charge and right 25 cents per number of text message is the charge. So the expression, right, ends up being 35 plus 0.25t. So then, right, each month, all that Tomas would need to do, right, is insert however many texts he sent to figure out his phone bill. Okay? Is everyone feeling okay still about these translation steps? Good. And yeah, it's definitely going to be, of course, the first part of the battle. And I think, setting it up and setting it up with confidence is probably the hardest. We don't have to worry too much about example 6 because it's just kind of undoing, right? So we're just going from the numerical back to the verbal or written style. So if we have 3m plus 4, 3m plus 4 is 3 times the number m plus 4. Okay. So hopefully that connection is making sense for everyone, right? And hopefully, like I said, we can kind of work between the two, okay? All right. So then our next example, right, is what we were warming up with. So this is our evaluating step because, right, we know we have a value for our unknown, okay? Right. So we've seen this before, shouldn't be anything new. So if we have evaluate x plus 7 when x equals -2. So we just plug in our -2, right? And then perform the operation. So -2 plus 7 is +5, okay? And then, right, if there's more, when there's more than one operation, use the order of operations, okay? All right, and we already practiced this, so I think you guys should be good. Stop me, slow me down if you guys need me to explain more, okay? All right, and then here's, right, the order of example or order of operations. So now, right, you have two variables, you have an A and a B. So now you have one value for A and one value for B, okay? So you're still doing the plugging in, right? Just make sure you know which value is which, right? So now we have -10 plus 4 times 1.5. So we do our multiplying first. 4 times 1.5 is 6. And then -10 plus 6 is -4, right? So when A is -10 and B is 1.5, right? The value of the expression is -4. Okay. All right, let's look at this vocabulary down at the bottom, because like I said, it's really, right, helpful when we know the language, right, being used. What is it referring to? And of course, hopefully, you might see some of this in your test questions. So hopefully now you'll feel like you know what it's asking. So go ahead and try. I'm gonna give you a few minutes, see if you can match the 7 words to their description or definition, okay? And then let me know when you're done. All right, did everyone get these matched up? Hopefully. So a number that is added or subtracted in a variable expression is what we call the constant term. Okay. So the constant is always the whatever's hanging out there, okay? B, a symbol that represents an unknown number or value is a variable, number 6. An expression written using a combination of words and numbers is probably a verbal expression. An expression that uses variables, numbers, and symbols for operators is D, an algebraic expression. The numerical factor of a variable is called the coefficient. And once again, it's just that number attached to the variable in our equations or expressions. We'll work on that. Another name for a variable expression is a symbolic expression, I guess. So F for number 5, and then, right, we can say numeric or mathematical expression. That's the one, right, without any variables. Okay. How is everyone feeling about this vocabulary that we use to talk about algebra?
I need a little work on it.
Okay, so I would definitely say, review this. We're going to talk about it more and more, but like I said, the more familiar we get with how these things are referred to, hopefully it'll, make things a little bit easier. But did everyone get these down correctly? All right, then let's move over. All right, let's just look at number 1 together here. To write an algebraic expression from a verbal expression, identify the key words. The unknown quantity in the expression is what the variable represents. Keywords also indicate what numbers and operations should be used. Not quite sure. What they want us to do there. I mean, kind of funny that the keywords in this passage are like keywords. I don't know. Anyway, let's continue. When evaluating the expression G plus 2H when G equals 4 and H equals -3, first substitute the given values for the variables. To avoid errors, make sure you substituted the correct values for each variable, especially if there's more than one variable. The second step is to perform the operation or use the order of operations. And if there is use the order of operations if there's more than one operation. In this case, right, multiply first and then add, right? So H equals -3, so 2 times -3 is -6. 4 minus 6 is -2. Okay. So go ahead and just work on the 4 multiple choice questions down here at the bottom, the skills practice, okay? I'm gonna let you guys work on these 4 for a little bit. I'm gonna excuse myself briefly, okay? But you should know what to do here, okay? Hi, Curtis, glad you could join us. Hopefully you see what we're working on. This is a new lesson, so if I need to send it up to Shannon or Jessica, let me know, okay, so they can print it out for you. Now, all right, you ready? Okay, thank you for being patient. Hopefully everyone's got their answers for numbers 1 through. So, Yeah. All right. What is the value of S plus 5t when S equals 3 and t equals -2? What did you guys choose for this one? A, B, C, or D? Okay. Everyone's being shy. It is the end of the week. I understand. All right. So we end up having 3 plus 5 times -2. So I do my multiplication first. 5 times -2 is -7. So 3 plus -7, or sorry, not 10. -7 is the answer. So hopefully everyone got B for number 1. All right, number 2, which phrase best describes the expression this?
Put D.
B, 8 minus 3 times a number.
D.
Oh, D, 3 times the number and -8. 3 times the number X and -8. Did anyone choose anything other than B?
C.
C, okay. So, good, thank you. Okay, so April and Melissa are feeling it's C. I agree. So Brittany, this one, 3 times the number X and -8, I guess would be more like 3 times X times -8 is the way I would read that expression. But you can see here, right? 3 times the number X. And then, right, decreased by 8. So hopefully everyone noticed, like B would be the opposite, right? B, you have your 8 minus, right, 3X, right? Because it's 8 minus 3 times a number as opposed to 3 times. So that always tells you what goes first, right? And then, oh, I guess the number X less 8 times 3. So I guess that would be like X minus 8 times 3. But does everyone see why C is the answer there? And Brittany, you kind of see why, yeah. So D was kind of close, but when you just say, like usually in our verbal expressions, I don't know if we would use a negative number, but we'd say like subtracted, decreased by, minus is going to be more of what we would see there. Okay. Spencer, we've made it to 139 and we're going through the 4 problems at the bottom there. Okay. Jamila bought a ladder and rented a rototiller to do some work in her backyard. The ladder costs $48.75. And the cost to rent the rototiller is just $18 a day. Which expression can Jamila use to find the cost of doing work in her yard? So what did you guys choose for number 3?
D.
D? Does everyone agree with Melissa? I sure do. Good. Good job, April. Good. So cool, right? Here's the cost of the ladder rental, and I guess there's no, and then, right, we have $18 per day on the rototiller, and of course she needs both of those items. And so, right, she can figure out, right, she knows how many days of work she has to do, right, then she can calculate her rental costs. Beautiful. Okay, which expression represents -17 less than the product of -12 and some number? What did you guys get for this one? No? C? So April likes C for this one. Does everyone agree? And yeah, this is the one that always, yeah, is like, for me, the most challenging. So 17 less than, and hopefully everyone knows, right, the product of is multiply, right? That's one of our multiply words. Okay, good. And so it's the product of -12 and some number, right? And then -17 less than that, right? So here's our -17 and here's our less than that. So awesome work, April. Does everyone agree with C for number 4? Is anyone confused? And so, yeah, and then like I said, so like this one, right? When it's something less than this, then that means this goes second. Whereas once again, right here, right, if it's 8 minus, then this is first minus second. Whereas this is first minus second. Yeah. Anyway, good job, guys. All right, let's continue. Okay, so hopefully everyone's feeling good about expressions. I think everyone is getting that nicely. So let's move into our equations then. Okay. And so first, let's just warm up, right? So the sum of 4 and a number, 3 times a number decreased by 1. The number split into 8 equal parts. Right? And if you see this, right, split into equal parts, right? That means divide. Okay. That's one of our divide keywords, yeah. Okay, and then evaluating each expression when x is -1 and y is +3. So -1 minus 3 is -4. 2 times -1 is -2. I'm sorry, 2 times 3, sorry, because we have a y here. 2 times 3 is 6, plus 1 is 7. And then here, -1 plus 3 is +2, and then 3 times 2 is 6. All right, is everyone feeling? I know I keep asking, but hopefully this feels okay. Okay. All right, so an equation is a mathematical statement that 2 expressions are equal. Okay, so that's why this word equa, right? Why that beginning of it has that, right? In algebra, an equation has at least one variable which represents an unknown variable. Okay. If it's not an equation, right? If it's just an expression, then we just use the order of operations, right? And simplify it. And then of course the equation has, right, an equal sign placed between the 2 expressions to show a mathematical statement of equivalence. Okay. All right, so then what does this look like? Well, Bao works 4 hours and earns $72. Write an equation that can be used to find out how much he earns per hour. Okay, so our first step is always to identify the variable. What don't we know? We don't know his hourly rates. We know how long he worked and we know how much his total earnings were, but what was the rate? Okay, identify the operation. Multiply the number of hours by dollars per hour to get the total earnings, right? So 4D, right, or 4 times D is what we're going to do, right? And then we write the equation, right? 4D equals 72. Okay. Does this equation make sense? Would you guys have been able to read these two sentences and get to there? Hopefully, okay. And so then a solution of an equation is the value of the variable that makes the equation statement true. So can anyone tell me, what does D equal? Or how could we figure that out if we couldn't do it in our head?
Do we have to divide
What are we gonna divide?
the 4?
Good, we're gonna divide both sides by 4. So then, like I said, my brain doesn't really want to do a lot of head math right now. So 72 divided by 4. So we know that, right? D equals 18, basically $18, right? Right? So good. So we know that bow makes $18 an hour, or at least did this day. Okay. All right, so then kind of similar to what we did when we were evaluating expressions, right? You might see something like, is 13 a solution of the equation x plus 12 equals 25? Right, so you do that same substitution step. So we're saying, if x equals 13, is this true? Right? And so, so I guess we're supposed to know yes, right? Wait, why did we go from weird? It's like step 1, step 2, and I feel like step 2 isn't even finished, but hopefully everyone agrees, right? Yes, right? In this equation, x equals 13. If x doesn't equal 13, then this statement isn't true, right? It isn't truly equal. Does that make sense? But this, right? Yes, right? 13 plus 12 is the same as 25, right? It's just two ways of representing that amount.
So x is equal to 13.
Mm-hmm.
How do you get 13?
Well, here they just asked us to substitute, but what we would do, right, is if this is our equation here, yep, you're just going to subtract 12 from both sides. So 25 minus 12 is 13. Yeah. Yep, you got it. Any other questions? Okay, so we'll continue this next Thursday. Okay. If you want to work ahead, you can. If not, just save this. And like I said, we'll do percents on Tuesday, algebra on Thursday. Is that feeling okay, or is it too confusing to jump between different topics? So April, this is a lesson that we started today. So it says review chapter 4 on the first page, but that's actually, we wanted to start on chapter 5. So you might not have these materials because they're new just for today, but we were on page, it's called page 137 was how far we got to page 140, and then we're gonna continue from there next Thursday. Does that make sense? So if you guys are good to go, you're welcome to leave the meeting. There are paper copies of this available in the blue binder for you to come grab if you need to pick up paper copies from our campus. And then, like I said, Curtis, if you need printouts, just let me know and I'll get a hold of Shannon or Jessica and print this stuff out for you, okay? All right, anything else? Okay. Cool.
Have a good day, Julie.
All right, sounds good.
Bye.
Okay, I'll see everyone around. There is social studies at 1 o'clock today. If anyone is interested to go to that, and then I will be in science at 4 o'clock. So maybe I'll see you guys then. All right. Farewell.